Since a data warehouse serves other teams also, it is crucial to learn how to provide access to the data warehouse while keeping to data governance best practices. Remember that once you've got data where it can be useful and it's in a usable condition, we need to add value to the data through analytics and machine learning. And that's typically done by other teams. So these teams will rely on our data. There are many such teams that rely on your data warehouse and partnerships with data engineering teams so that they can build and maintain new data pipelines. The three most common clients are machine learning engineers, data or business analysts, and other data engineers. Let's examine how each of these roles interacts with your data warehouse and how data engineers can best partner with them. As you will see in our course on machine learning, a machine learning team's models rely on having lots of high quality input data to create, train, test, evaluate, and serve their models. They'll often partner with data engineering teams to build pipelines and data sets that they can use in their models. Two common requests that you might have to field are: how long does it take for a transaction to make it from raw data all the way into the data warehouse? What the machine learning team is asking for is that they want the data that they train their models on to be available at prediction time as well. If there's a long delay in collecting and aggregating the raw data, it will impact the machine learning team's ability to create useful models. A second question that you will definitely get asked is how difficult it would be to add more columns or more rows of data into certain data sets. Again, the machine learning team relies on teasing out relationships between columns of data and having a rich history to train models on. You will earn the trust of your partner machine learning teams by making your datasets easily discoverable, documented, and available to them to experiment on quickly. A unique feature of BigQuery is that you can create high-performing machine learning models directly in BigQuery using just SQL by using BigQuery ML. Here's the actual model code to create a model, evaluate it, and then make predictions. You will see this again in our lectures on machine learning later on. Another critical stakeholder is your business intelligence or data analyst teams. These teams rely on good, clean data so that they can query it for insights and build dashboards. These teams need datasets that have clearly defined schema definitions, the ability to quickly preview rows, and the performance to scale to many concurrent dashboard users. One of the Google Cloud products that helps manage the performance of dashboards is BigQuery BI Engine, which is in beta at the time we recorded this. BI Engine is a fast, in-memory analysis service that is built directly into BigQuery and available to speed up your business intelligence applications. Historically, BI teams would have to build, manage, and optimize their own BI servers and what are known as OLAP cubes to support reporting applications. Now, with BI Engine, you can get sub-second query response time on your BigQuery datasets without having to create your own cubes. BI Engine is built on top of the same BigQuery storage and compute architecture and serves as a fast, in-memory, intelligent caching service that maintains state. One last stakeholder of your data engineering team is other data engineers that rely on the uptime and performance of your data warehouse and pipelines for their downstream data lakes and data warehouses. They will often ask, how can you ensure that this data pipeline that we depend on will always be available when we need it? Or they might ask, we're noticing high demand for certain really popular data sets. Can you monitor and scale the health of your entire data ecosystem so we know that the data is available whenever we need it? One popular way to monitor the health of your ecosystem is to use built-in Stackdriver monitoring of all resources on Google Cloud Platform. Since Google Cloud Storage and BigQuery are resources, you can set up alerts and notifications for metrics like query count or bytes of data processed so that you can better track usage, performance, and cost. Another reason why you might use Stackdriver is so that you can track spending of all the different resources used and what the billing trends are for your team or organization. You can even use Stackdriver to create cloud audit logs to view actual query job information and look at granular level details about which queries were run and who ran them. This is particularly useful if you have sensitive data sets that you need to monitor closely. And that's a topic that we will discuss later.